Physics, heat transfer, and heat capacitance. So to describe this, we have an example here of a 5 kilogram cast iron pan being heated on a stove from 300 Kelvin to 450 Kelvin. How much heat is transferred to the pan in kilojoules, or kg, or kJ? So, for our knowns, we have our pan of mass 5 kilograms. We have our heat capacitance, a C, which is going to be 450 joules per kilogram Kelvin. T1, or temperature 1, initial temperature, is equal to 300 Kelvin, and our final temperature is equal to 450 Kelvin. And then what we're trying to find is the amount of heat going in, so Qn. Typically energy is in units of E, but for Q that's just a standard notation implying heat transfer. So, first thing with physics problems is drawing yourself a picture of what we have. So here we have a pan, and then we have heat being conducted in. And so with this heat being conducted in, we know that we've got a closed system because we don't have any heat being conducted out, and we're not talking about any sort of other heat transfers. So basically this system is going to be closed, and we're just talking about the amount of energy to warm this pan up. So for the basic conduction equation, we have delta Q, so the change in thermal energy, is equal to mass times heat capacitance times the change in temperature. We can go ahead and rewrite this to say the change in Q is going to be basically the amount that we're putting in, so Qn is equal to mass times heat capacitance times our change in temperature, which is going to be T2 minus T1. So that is basically you've got T2, which is your higher, minus your lower. And that'll tell us the amount of energy that has been put into the system. So continuing on with that, we have Qn is equal to mass of 5 kilograms times heat capacitance of 450 joules per kilogram Kelvin times T2 450 kelvins minus 300 Kelvin. When you go ahead and solve this out, Qn is equal to 337,500 joules, thereabouts. This you need to convert to kilojoules, which is going to be approximately 338 kilojoules. So a very, very large amount of energy just to warm up this pan 150 degrees Kelvin.